video, in your function video, you guys should have learned about inputs and outputs, right? And then this process here is kind of your machine, right? The process is your machine. So, what is the numbered order? Is this my inputs or outputs? Awesome. These are my inputs, right? These are what I'm choosing to put in my machine. Okay? So what is this? This is my function machine. You're going to plug it in. Okay? And then my cost in dollars is going to be my what? Awesome. Your output. Okay? So what does this mean, Ms. Cullen? This means I'm going to take my number ordered, I'm going to put it in my process and see what is going to come out in my cost in dollars. Okay, it should make logical sense too, right? If you are ordering roses, the amount it's going to cost is dependent on how many roses you order, right? Okay, so that makes sense. So, how I'd like you to show your work on this is you're going to take that numbered order and you're going to plug it in, right? I'm going to say, okay, well, this says that it's going to be $20 plus 75 cents per rose I order. That's what this machine says. It's just a base fee of $20 plus 75 cents per number you order. Okay? So what's my total cost here? I don't expect you to do this in your head. I do expect you to plug it into your calculator. So everybody in this class should have a calculator. You need to go to the bookstore and say you're in my class, and they'll give you a calculator if you don't have one. All right? Now, when you plug this in, you got to be careful because you got to think of order of operations. Who's heard of PEMDAS? Good. PEMDAS. Multiplication comes before adding, right? So I got to multiply these before I add the 20. So when I plug this into my calculator, Ms. Cullen, I first do 0.75, not 75, but 0.75, 75 cents. If you were paying $75 per rose, that'd be pretty dang expensive, huh? Okay, so 75 cents, 0.75 times 5. Then plus 20. Okay, if you want to plug this whole thing into your calculator at once, you have to put the 0.75 times 5 in parentheses. And then your calculator will do that first. Okay, so what do we get? 23.75. Awesome. I want you guys to keep going. I'm going to call 2 volunteers to come up and write the other 2 for me. Work with your partner right now. I'm going to have 2 people come up. Tell me what they get. Awesome. I agree. Okay. So we take those numbers, put them in our machine, or substitute them into our equation. If we order 12 roses, it's going to be 29 bucks. If we order 22 roses, it's going to be 36 bucks. Okay? So here, we're going to talk about this a lot in this class, a general rule. Okay? This X here, right? What does that mean, Ms. Cullen? Well, this says that, okay, what is our general rule for however many we order, right? We can basically take any number and substitute it into our machine and get an output, right? Any input and get an output. So we can write a general algebraic rule, all right? So I'm going to follow the same thing and say, okay, well, for any number, that's what X stands for. For any number, my total cost will be $20 plus 75 cents per rose. So that would be my, yeah, I'm going to do it like that, okay? That would be my rule, and that would be how I would say it in words, Okay. So down here, well, first, do we have any questions about the general rule? Okay. So if I ask you for an algebraic rule, you're going to give me the general term. Okay. You guys should be able to do, I'm going to have you guys do the next one by yourselves. Okay. And it's pretty much the same thing, but now they're saying, okay, it sells roses for a service charge of $60. Okay, so not $20 this time. This time it's going to be $60, and then, but it's only going to be 50 cents per rose. Okay. So basically, a lot of the times you'll see these in determining which one's the better move. Okay, which one's the better deal. Well, you're going to do flower power. We did roses or red together. So it has this line here, right? On this line, I want your general rule. Well, my general rule for roses or red is my total cost equals $20 plus 75 cents. Okay? You're going to write your general rule for flower power, which will be the same thing you write here, there. And then you're going to circle which one's the better deal. Okay? You can tell that by looking at your tables, right? Well, which one's cheaper? Any questions? All right, so you're going to come back to that. We're going to keep doing some notes together, and then you guys will come back and finish whatever we don't do. Okay? That's how this class kind of works. Okay. Here it says, compare the two graphs below for the two flower companies. Write the similarities and differences you notice. Okay? So take a minute with your partner, start talking about some similarities and differences, and I'll have you guys come up here and write them. So we have that they start at different points, right? Awesome. The roses are red starts at 20, right? Where flower power, you first initially have to pay 60 bucks. All right? We have positive. Positive what? They are positive, but they're positive what? Yes? Oh, yes. Awesome. Positive slopes. What is slope? What does that mean? Yeah. Erica says y equals mx plus b. Awesome. That is the slope-intercept form, right? Okay. Y equals mx plus b. Slope is basically the steepness, right? It's a constant rate of change. Okay? So both of these lines have a slope, and both of these lines have a positive slope. They don't have the same slope. Okay, so that's actually something that's different. Their slopes are different, but they're both positive slopes. Okay? You know what slope is? You'll kind of remember it as staircases. Does anyone remember that? Stairs. Okay. So they do have different slopes, and that's kind of what we said in green here, right? They increase by different numbers. That's their constant rate of change. Their constant rate of change, or their slope, is different. Awesome. That's the same thing. These equal the same thing. Okay? Now we have the flower power is steeper. Is that true? Flower power is higher. It starts higher up. But is it steeper? What does steep mean? Okay. Which would you say is steeper? Which graph is steeper?
The roses are red.
Good. Roses are red is actually steeper, right? Because flower power, think of it if you were hiking up that hill, which one you'd want to hike up. Okay? Flower power is a little more constant, right? If you look at it. Where roses are red, it's increasing rapidly. It's definitely steeper. If you're not sure, draw staircases. See which staircase looks steeper, right? Well, actually this one would be like this, right? That one's clearly steeper when I draw my staircases. So not flower power, but roses are red is steeper. Okay? So it's important that we can look at graphs and we can determine some information from that.